Delivery approaches shape how software moves from idea to operation, and they directly affect when feedback arrives and where controls can be integrated effectively.
The choice of approach influences how early problems surface, how often changes occur, and how much structure exists around approval and validation. From a security perspective, this matters because risk is not static, and the timing of detection often determines the cost and impact of fixing issues.
Different approaches trade predictability, speed, and flexibility in distinct ways, which means security integration must adapt rather than rely on a single pattern.
Understanding these differences allows teams to align controls with reality instead of fighting the delivery model.
Before we continue, a quick note. This audio course is a companion to the CISS books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A sequential approach like Waterfall is best suited to environments where requirements are stable, well understood, and unlikely to change significantly during development. Work progresses through defined phases, and each phase is expected to reach completion before the next begins. This structure provides clarity, documentation, and formal checkpoints that can be useful in regulated or safety-sensitive contexts. From a governance standpoint, it offers clear moments to review decisions and confirm readiness. The predictability of this model can simplify planning, but it also assumes that early understanding is accurate.
One of the primary risks of a sequential model is that security issues may not be discovered until late in the process, when testing finally occurs. When problems emerge after design and implementation are considered complete, remediation often requires revisiting earlier decisions that were assumed to be settled. This can create resistance to change, pressure to accept risk, or costly rework that delays delivery. Late discovery also limits the opportunity to adjust architecture because foundational choices may already be embedded. As a result, security in this model must be addressed deliberately and early, rather than relying on downstream validation to catch issues.
Iterative approaches like Agile organize work into short cycles with frequent reassessment of priorities and requirements. Instead of committing to a fixed scope up front, teams maintain a backlog that evolves as understanding improves. Planning occurs repeatedly, allowing new information to influence direction without restarting the entire project. This flexibility supports responsiveness to business needs and emerging risks. For security, it creates opportunities to validate assumptions earlier and more often.
Agile delivery enables earlier validation of security requirements because working increments are produced quickly and reviewed continuously. Features that handle sensitive data or enforce access controls can be examined while change is still inexpensive. Security expectations can be refined as part of backlog grooming rather than treated as fixed constraints that may no longer fit reality. This approach reduces the chance that misunderstandings persist unnoticed until the end. However, the pace of change also means security must be lightweight and repeatable to keep up.
DevOps extends iterative delivery by integrating development and operations responsibilities into a shared workflow. The emphasis is on automation, collaboration, and rapid movement from code to production. This approach reduces friction between teams and shortens feedback loops dramatically. From a security perspective, it eliminates the possibility of relying on slow, manual reviews at the end of delivery. Controls must be built into the pipeline and observable in production, because deployment happens frequently and often without ceremony.
Continuous integration and continuous delivery pipelines automate build, test, and deployment steps so changes can be released repeatedly and reliably. Automation enforces consistency, reducing the risk introduced by manual handling and ad hoc procedures. Security checks can be embedded alongside functional tests, ensuring that validation occurs every time rather than only during special reviews.
Pipelines also create an audit trail of what was built, tested, and deployed, which supports accountability. The reliability of these pipelines becomes a security concern in its own right because trust in automation underpins trust in releases.
As change frequency increases, the need for automated controls and consistent guardrails becomes unavoidable. Manual approvals and reviews do not scale when deployments occur daily or even multiple times per day. Instead, policies must be translated into automated checks that enforce minimum standards consistently. Guardrails define what is allowed and what is blocked, providing safety without requiring constant human intervention. This shift changes the role of security from gatekeeper to designer of constraints that operate continuously.
Modern release strategies reflect this need to manage risk while maintaining speed.
Techniques such as blue-green deployment allow new versions to run alongside existing ones, reducing downtime and simplifying rollback.
Canary releases expose changes to a small portion of traffic first, providing early signals before full rollout.
Phased deployments expand availability gradually, balancing caution with progress.
These strategies support security by limiting blast radius and providing time to observe behavior under real conditions. Security integration must fit the cadence of the chosen delivery approach because mismatched controls create friction or are bypassed entirely.
In slower models, formal gates and approvals can be effective because they align with existing phase boundaries.
In faster models, those same gates become obstacles that teams learn to route around. Instead, security checks must be automated, contextual, and tied to risk rather than to arbitrary milestones.
Approvals shift from individual changes to patterns, policies, and exceptions that are managed centrally.
Artifact integrity is a shared concern across all approaches, even though the mechanics differ. Controlled builds ensure that what is tested is exactly what is deployed, without manual modification.
Verification of deployment packages protects against tampering and accidental substitution.
In automated environments, this integrity is enforced through tooling and cryptographic verification rather than through manual inspection.
Trust in artifacts allows teams to move quickly without sacrificing confidence.
Observability becomes increasingly important as delivery accelerates because not every issue can be caught before release. Monitoring, logging, and alerting provide visibility into how systems behave after change.
This visibility supports rapid detection of defects, misconfigurations, and security regressions that appear only under real usage.
Observability shifts some security assurance from pre-release certainty to post-release detection and response. When combined with safe release strategies, it allows learning without catastrophic failure. Governance must adapt to these different approaches by defining a core set of controls that remain constant regardless of delivery speed. These controls establish non-negotiable expectations, such as access management, logging, and integrity checks. Other controls can vary in implementation to match cadence, risk, and environment. Effective governance focuses on outcomes rather than rigid process, ensuring that protection persists even as methods change.
This flexibility prevents governance from becoming an obstacle to delivery.
Each delivery approach represents a different balance among predictability, speed, and placement of control points. Sequential models favor certainty and formal completion, but risk late discovery of issues.
Iterative models favor adaptability and early feedback, but require discipline to maintain consistency.
Integrated models emphasize speed and automation, demanding embedded controls and strong observability. Security succeeds when it adapts to these realities, placing the right controls at the right points rather than insisting on a single pattern everywhere.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.